Today we're looking at an equation of tangents, but this time we're looking at it in terms of trigonometric functions. Now we've learned in the past when it comes to trigonometric functions we have that direct relationship to the unit circle. So just like when we looked at equation of tangents normally, we did our follow through. We found y1, then we found the derivative, then we did substituted the x value into the derivative, found the gradient of the tangent, then used our equation to find the equation of the rule. We're going to do exactly the same process that we did this time with a trigonometric function. So the only difference here is our x value is now a radian. So that means we have to come back and look at our unit circle and identify where is that going to be in terms of our coordinates. So let's get into it. So the first step here is we're going to find out when f of x is equal to pi on 6. So we can get that y1 coordinate. So in this case here, we'll have 3 times sine times 2 lots of pi on 6. Which if we look at this here, we can actually simplify this through and get 3 sine 2 pi on 6, which is the same as 3 sine pi on 3. So we've now got what our substitution value is. What we're looking for when we look at in trigonometry is this section here, sine pi on 3. So we come back and we think to ourselves, well, where would sine pi on 3 lie? And we know in the unit circle that sine pi on 3 would lie somewhere around here. Okay, so around pi on 3 here. Now we go back and think about our coordinates. The coordinates for pi on 3 would be 1/2 and root 3 on 2. When we're looking at trigonometry, we need to recall in our mind that all the x coordinates represented by a cosine and all the y coordinates are represented by a sine. So in this case here, because we're looking at sine pi on 3, we're looking for the y coordinate. So we're going to replace this sine pi on 3 now with root 3 on 2. So therefore your final answer here becomes 3 times root 3 on 2. And this here is what y1 equals. So 3 times root 3 on 2. So we've done our first step, found what our y1 is going to be. So let's now find our second step where we differentiate this function. So if we differentiate this function, the derivative of 3 sine 2x becomes 6 cosine 2x. Remembering our trigonometric differentiation. Now we've got our gradient, we can now do our substitution of pi on 6 into this. So we get 6 cosine 2 pi on 6. And if we look at this kind of calculation, we should get something that's kind of similar to this. So we'll get 6 cosine 2 pi on 6, which then becomes 6 cosine pi on 3. So we're still in the same area in our unit circle, but this time instead of looking at the sine function, we're now looking at the cosine. And we know from here cosine is the x, so therefore I can now replace cosine pi on 3 with 1/2. So my final answer here will be 6 times 1/2, which is then equal to 6 over 12, which equals 3. So therefore, my gradient of the tangent is equal to 3. We've now got everything that we need to be able to calculate the gradient of the equation of the gradient of the tangent. So if we write that over here, we'll have y minus y1 is equal to m x minus x1. So let's place in everything we know. We know that y1 is equal to 3 root 3 on 2. Our gradient is equal to 3 and our x1 is pi on 6. And just like you did with the normal kind of equation of tangent, let's just follow through the process. So y minus 3 root 3 on 2 is equal to 3x. Now we can do 3 times pi on 6, which then gives us pi on 2. Okay, so minus pi on 2, and then bring her across the last part. 3x minus pi on 2 plus root 3 on 2. Now you could leave your answer if you want to in that format. However, another way you can write this is 3x plus 3 root 3 on 2 minus, what's that? Minus pi all over 2. So both of these here are acceptable answers. All I've done in the second half was simplify because I have the same denominator. So let's have a look at what we've done here. We've used the unit circle to help us work out what our y coordinates is when we have a radian that's equivalent to the coordinates set in the unit circle. We looked at how x and y relate to cosine and sine, and knowing that if we're looking for sine, we look at the y coordinate at that particular point in your radians, okay? And if we look at cosine, we look at the x coordinate at that particular point of the radian of pi on 3 here. And then we follow through the same process in terms of finding the equation of tangent. Good luck.